Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review mean, median, mode, and range. So definitions of mean, median, and mode are here. Mean, which is colloquially called the average, is where you add up all the scores divided by how many there are. The median is either the middle score or the mean of the two middle scores, and the mode is the most common. Now, just remember with mode, you can have more than one mode, and it's also possible you have no modes. So these three in blue are measures of central tendency. The point of them is to give an indication about the center of the data, to give an indication about a typical score. The range, on the other hand, is a measure of spread. It's supposed to tell us how spread out the data is. It's just the highest score minus the lowest score. So just be aware that these three and the range, they are used for different purposes. They're sort of reporting on different things. All right, let's have a go at calculating mean, median, mode, and range. So let's look at these 6 scores here. Now, this score here of 20 is referred to as an outlier. An outlier is sort of an unusual observation. It's like a score that's much higher or much lower than the rest of them. So outliers can affect your data, and I'll show you that in a second. Now, we don't have a purely mathematical definition for outliers yet. You will learn that later in your maths career. For now, you can just look at the data and say, oh yeah, that score's a long way above or a long way below the rest. Okay, let's calculate mean, median, mode, and range of this data. I'm going to do it with the outlier, then without the outlier. So, to calculate the mean, I add up all these scores and divide by how many there are. So if I add each of these scores, of course you can use a calculator, I get 72. I divide by 6 because there are 6 scores. The mean is 72 divided 6, which is 12. Now let's calculate the median. The median's the middle score, but it must be when the scores are in order. So the first thing I need to do to calculate the median here is write the scores in order from smallest to largest. Now here there are 6 scores. When the number of scores is even, there will be 2 middle scores. So when you have 2 middle scores, the median is halfway between. If you're not sure what the number halfway between is, you add these 2 up and divide by 2. So 10 plus 12 is 22, divide 2 is 11. The median's 11, it's halfway between the 2 middle scores. The mode is the most common score. Well, here 8 is the only score that's repeated, so the mode would be 8. Now, if no scores are repeated, then there are no modes. If there are multiple scores that have the same highest frequency, the data can have 2 modes, it can have 3 modes, whatever. All right, the range for this data is simply highest minus lowest. So it's 20 minus 8, which is 12. Just be careful when you're asked to give the range, the answer should be one number only. Some people write like 8 to 20 or something like that. That's not the range. The range is one number, and it's calculated by highest score minus lowest score. All right, let's now look at the data. This time we're going to exclude the outlier. So we're going to calculate mean, median, mode, and range of just these scores here. So the mean, the 5 scores left, they add up to 52, and there are 5 scores. So the mean is going to be 10.4. Now for the median. Now when there's an odd number of scores, as there are here, there will be one middle score, and it's this score here, which is 10. Median is now 10. So the mode hasn't changed, it's still 8, and the range is highest minus lowest, 14 minus 8, which is 6. So we can see here that when we took away the outlier, the mean and the range changed by more than the median and the mode. So for that reason, we say that the mean is more susceptible to outliers than is the median or the mode. Outliers drag the mean up or down a lot more so than they do for the median and mode. And it's for that reason sometimes we don't report the mean, we report the median instead. An example would be house prices. So for house prices, there's a lot of houses that are very similar in cost, and then there's a few outliers that are really, really expensive houses. They drag up the mean, but not the median, and that's why the median house price is usually reported, not the mean. All right, let's now look at using this knowledge to find an unknown score. So here we have 4 scores, one which we don't know. We're going to calculate x, firstly if the mode is 32, then if the median's 22.5, then if the mean is 21. So if the mode of these scores here is 32, x must be 32. We must have 32 as the most common score. That's the only possible option. All right, let's now look if the median is 22.5. So there's an even number of scores here. The median will be halfway between the two middle scores. So as I said in the previous slide, when there are two middle scores, you can find the median by adding them up and dividing by 2. So here we're told that that number is 22.5. So let's just solve this equation. Timesing each side by 2, we get 18 plus x equals 45, and then we simply subtract 18 from both sides to get 27. This score must be 27 if the median of the 4 numbers is 22.5. All right, what about the mean? Well, we're going to do something similar. The mean is found by adding up all of the scores and dividing by how many there are. So in this case, I'm going to divide by 4 because there are 4 scores. So this is the mean, and we're told the mean equals 21. So let's go ahead and solve this. 10 plus 18 plus 32 is 60. So on top we have 60 plus x, on the bottom 4, and that equals 21. All right, we solve this equation just like we solved this one here. Multiply each side by 4 to get rid of the fraction. I get 60 plus x equals 84, and then I simply subtract 60 from both sides. X is 24. So in this example, if the mean of these 4 scores is 21, x, this score here, must be 24. All right, let's look at one harder example now. My team has played 15 matches and we averaged 2.8 goals per match. So here I mean the mean number of goals scored per match is 2.8. And I'm asking how many goals we must score in our next match in order to raise our average to 3 goals per match. Okay, problem here is, unlike the previous slide, we don't know all of the scores, but we don't actually need to know them. Because this question's asking about the mean, and we know that the mean is the sum of the scores divided by n. N here means the number of scores. So consequently, if you times the mean by the number of scores, you get the sum. So what does that mean in the context of this question? Well, if we have a mean of 2.8 goals per match and we've played 15 matches, we must have scored 2.8 times 15. We must have scored 42 goals in total. Now we want our mean to be 3. If we play one more match, we've now played 16 matches. So if our mean is to be 3 goals per match after 16 matches, we must have scored 48 goals. So 42 is what we'd scored before, and 48 is what we want to have scored after. So we've currently scored 42 goals. We need to score 48 by the end of next match to have an average of 3. So clearly the answer here is 6. We need to score 6 goals in our next match to increase our mean number of goals to 3 goals per match. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.